Welcome to the International Copper Association's Copper Connections podcast. I'm Nicole Witoslawski, Marketing Communications Manager for the International Copper Association, or the ICA. My colleague, Malcolm Burwell, North American Director of Technology Development and Transfer for the ICA, will be talking to Jack Lifton today. Jack is the founder of Technology Metals Research. He's also a consultant, an author, and a lecturer on the market fundamentals of the technology metals, a term he uses to describe strategic rare metals whose electronics properties make technology, as we consumers know it, possible. Jack is also a physical chemist who specializes in high-temperature metallurgy. He will be a featured presenter at the Society for Automotive Engineers Powertrain Electric Motor Symposium on Monday, April 23rd at the Book Cadillac Hotel in Detroit. The title of his presentation is The Supply of Heavy Rare Earth Metals and the Demand for Them by the Global OEM Automotive Industry. Thanks for joining us, Jack. Malcolm?
Jack, thank you very much for joining us today. I know that you're a physical chemist by training and you specialized in high-temperature metallurgy before you became marketing and manufacturing executive. Could you tell us about the work that you're doing today, especially the work around rare earth metals, and why you think that supply and demand is a significant global issue?
I'm actually very much involved in the rare earth metal industry today. I started out as an analyst, really. After retiring, I became today I'm an executive in a venture, and I'm on the boards of a couple of companies, and my focus is on processing the rare earths. I've written a lot and I've studied a lot about the junior miners, the exploration companies, and I've seen the few developed miners, and I'm now focused on processing because that's the choke point in the entire world. Today, overwhelmingly, the rare earths are processed in China, something on the order of 95%. That's what they're always talking about, the 90+% issue. It's the processing. China does not have a monopoly on the world's rare earth deposits. It has a monopoly, actually literally a monopoly, on the processing of the rare earths. That's the problem. In order for any supply chain to ever exist again without control by China, it will require developing the components of the supply chain that are either now gone from the Western world or never existed.
And that supply chain, as it affects the automotive industry, how critical are rare earths in this industry, particularly when we think of the production of electric vehicles?
Well, actually, I think that the issue of the electric vehicle is not the issue that's most important. It turns out that the average internal combustion engine-powered vehicle contains about a pound of rare earth metals. The average electric, let's say electric and hybrid vehicle, that figure can go to 3, 4, 5 pounds. But, okay, and so everyone keeps talking about, well, if they produce a lot of electric vehicles, there'll be a huge problem. There already is a huge problem. Last year, in the last 12 months, let's say, some 60 million vehicles were produced, requiring, on the average, 30 million pounds of rare earths, mostly specialized critical heavy rare earths. And so we're talking 15,000 tons of rare earths, which were turned into, typically, 60,000 tons of magnets, batteries, etc. The automotive industry, as it stands now, is the largest single user of rare earth on the planet as an industry. So right now, the more common rare earth, the term rare, as everyone I hope knows by now, is a misnomer. The more common of the rare earths are basically in good supply, other than the critical one, neodymium, used in rare earth permanent magnets, which may be in short supply. At the very best, it's a wash. But the heavy rare earths used in the automotive industry, dysprosium for magnets, terbium in lighting, yttrium in ceramics, europium in displays, these are already in short supply. They only come from China. They've always only come from China. And so unless we develop processing capability, it's not technology, everyone knows how to do this, capability out here outside of China, we're simply going to become more dependent on China for these things. And China claims to be cleaning up its environment and reorganizing a basically very loosely, if at all, regulated mining industry. And this is severely impacting the supply. I always tell people the analogy you have to think about is this. If I want to fix a car, I don't start the car to work on the engine. I turn it off. And the Chinese are trying to fix the mining industry, and they've turned it off as much as they can without closing down their industry. And therefore, they only produce really enough maybe for their own needs, and they will not export something beyond their own needs. Their own needs does include, however, export. Half of the rare earths produced in China are exported in the form of electric motors for cars or batteries, things like that. But the problem we have here is that every day that goes by, we become more dependent on China for these materials. And if the question always comes up, and I'm sure this is of interest to the Copper Association, obviously, why don't we substitute? Well, at the moment, we don't have to, because the Chinese seem to be continuing to export the finished goods. But the long-term fear, of course, is that something could happen there, that they might not produce it or they might not export it. And I have seen over the last few years the development of some really efficient, very nice, non-magnetic induction-type motors, such as obviously using copper, and electromagnet induction created electromagnets rather than permanent magnets. And quite frankly, to me today, the only difference I see between a rare earth permanent magnet motor and one that does not use permanent magnets or rare earth permanent magnets of any kind is a little bit of weight difference. I think that the non-rare earth permanent magnet motor, electric traction motor, is a bit heavier. The efficiency looks to me to be about the same. So I'm telling my rare earth industry clients that you need to get reliable supply. You need to control your costs and prices. The junior exploration rare earth miners were delighted last year when the Chinese began squeezing supply and Chinese speculators began controlling supply because the prices skyrocketed. They went all ridiculous. And they were going, oh, this stuff is wonderful. We're all going to be rich. And I said, you can produce all the gold you want, and there's never any lack of demand. There might be a change in demand. But gold, you can't produce enough. Everybody wants gold. That is not the case with anything else at all. The rare earth market is maybe 125,000 tons a year in total. It may grow to a couple of 100,000 tons over this decade. That's true. But being able to produce 201,000 tons in one mine is absolutely ridiculous and useless. This is a situation where if you cannot produce the exact item the industry wants, like the automotive industry, they'll move on to something else. And I warned them, if the industry engineers out rare earth permanent magnets, it would take 2 or 3 years to accomplish that, and then reintroducing them later would take another 2 or 3 years. So essentially, they'll be gone. Now, I'm 72 years old, and all of my life as an automotive supplier, I was told, do not increase the weight of the car by a gram, because the goal was to increase the fuel efficiency. And the best way to do that is decrease the weight and change nothing else. Okay, so that was the mantra. So the first time I heard that an induction traction motor for an electric vehicle would weigh an additional few kilos, I laughed because I knew they wouldn't do that. Today I'm not so sure. What I think is that other savings can be made, and I think the electric car program is going to go forward. And if the rare earth supplies are not there or not reliable, not credible, then I see the industry will simply start using induction motors. And I believe we're going to have both types of motors on the road within a year. Maybe they're on the road now, because I've seen an awful lot of really nice designs, finished designs for those motors, and samples sitting on the desk.
Thank you, Jack.
This concludes part 1 of Malcolm Burwell's interview with Jack Lifton. The discussion continues on part 2.